I saw him leave that class today.
All right. So, section 2.2 or 10.2 triangles. So the first part that I'm going to start with is just the classifying triangles by their sides. So the lesson you guys will have on Tuesday of next week will deal with classifying by their sides, classifying by their angles. You'll do some Pythagorean theorem. You guys will have some stuff where you will have similar triangles and I think there's one more thing I can't remember right off the top of my head. So, first part, when we classify triangles by their side, we're only looking at the measures of the sides of the triangle. So, if we have a triangle by its side, an isosceles triangle has two sides with the same measures. Okay, a scalene triangle. Anyone remember what that one was? No sides are the same. So scalene is 0 sides have the same length. I can't spell. And then the very last one, when we classify by sides, will be an equilateral triangle. It's going to be all three sides are the exact same. Okay, so that's classifying them by their sides. The next one's going to be when we look at the actual angles themselves. Okay, we'll have the triangles in front of us. We'll be able to look at the angles themselves. When we have an acute triangle, for acute, all the angles are less than 90. I'm going to write it as angles here. So acute angles, all angles are going to be less than 90 degrees. For the right triangle, you will have one angle that's exactly 90 degrees. And if this angle is exactly 90 degrees, that's where we can use like the Pythagorean theorem to figure out the other sides. This is the only one that really has a nice, easy formula for us to solve those ones. The obtuse angle. The obtuse angle has one angle greater than 90 degrees. Okay, and again, because triangles, we'll get this, triangles will only add up to 180 degrees, I'm only able to have one of those angles that'll be above 90, the other two will have to be acute. But just know, if you have one angle that's bigger than 90, it's obtuse. Okay. And the last one, the equiangular triangle. Every single angle is going to be 60 degrees. 60. Yep, they're all the exact same, and because they add up to 90 or 180, so all angles are 60 degrees. So 60, 60, 60, and it'll add up to 120. Okay. I left somebody else's drawings on there because why not? If you want to visually see what they look like or draw them, you most certainly can. But again, if they have the hash marks on the outside, that means we're measuring by the sides. If it has the arcs on the inside, that means we're measuring by the angles. So this one was showing 3 sides that are all the exact same length. That's why it's equilateral. This one has all different length sides. That's why it's scaling. This one has the one angle that's greater than 90, so that one's going to be obtuse. Again, this one's measuring by the sides. That's why it's going to be isosceles, because we have sides. And then again, equiangular and right triangle.
Is there not an acute one?
I don't have a cute. If you want, I can draw one, but.
Are we supposed to draw these?
If you want, you don't have to. I mean, if you know what they are, go for it. If you don't, go ahead and draw it. But again, I'm going to post the notes as soon as this class is over too.
Shut up. Sorry, I was marking this one.
Anybody need more time with pictures? Okay.
I really hope they make him. That'd be really cool. Just see him standing in the side.
Did he be able to sing over me?
I couldn't sing over us yesterday in practice. I love how Jess too has like 3 songs in English.
Three from the
Also, is this your? No.
Yeah, it's never throw it away. I meant to throw it away.
I saw the calligraphy and I thought it was
Oh.
just go on.
I'll give it a chance. I'm not going to rush through it.
Want to get it back ready?
Like physics? Okay, I'm sad to raise it. I'm not ready. Okay. Yeah. Okay. I don't mind going back to my class.
All right. So the next part, I'm not going to get too crazy into it. I'm just going to give you the definition. I'm not going to give you a bunch of examples. But it says the sum of angle measures in a triangle. All 3 angles will always add up to 180 degrees. So you've got angle A plus angle B plus angle C will always equal 180 degrees. No matter what, a triangle equals 180 degrees. Okay. So again, I'm not getting too crazy into that. Does that make sense? Anybody not remember that? Okay. Then I'm not going to give examples for it. Okay. Pythagorean theorem. Who remembers what the Pythagorean theorem was? Yes, ma'am.
A squared plus B squared equals C squared. Good job.
Okay. So Pythagorean theorem, a squared plus b squared equals c squared. In this one, it only works with a right triangle. Okay? I'm going to say only with a right triangle. And then c is the hypotenuse. Okay? So I'll do the one example. Hopefully you guys got it. And if you guys have it, I'm going to not spend a bunch of time on those ones. Okay, I've got this first one. It says the hypotenuse of a right triangle is 13 feet long. One leg's 5 feet. Find the length of the other leg. If you want to draw the picture, by all means, go for that. If the words work for you, that works too. Okay, I'm missing this side.
The hypotenuse is always across from
Yes, hypotenuse is always across from the right angle. And it's always going to be the biggest number. It'll always be the C.
always the biggest number.
Always the biggest number. All right, so if I start with this one, again, it's set up as a squared plus 5 squared equals 13 squared. That gives me a squared plus 25 equals 169. I'm going to subtract 169 minus 25. So a squared equals 144, or I can simplify it down and say a equals 12, because I have to do the square root on both sides.
It really doesn't matter A and B are like interchangeable.
Correct. Yep. Yeah, this could be the A that you don't know, and that could be the B. This could be the A, and that could be the B that you don't know. Okay, thumbs up, thumbs down. How you guys feeling on that one? Okay.
I'm feeling good.
This one, I'm not going to get into it, but if you really wanted to know, it's saying you're making a big sign. It looks like this. Whoops. Looks like this. And it says you want to find the diagonal. So they gave you 8. This is 10. You'd still use that to find the hypotenuse, which is that one. Okay? I'm not going to do it. I just want to show you. Again, if they're giving you a rectangle or a square, you can always cut it in half to find that diagonal brace. So if you're ever going to build something at home, or you have a gate that's starting to sag, that's to figure out how long that board needs to be.
Wait, did we solve it?
Nope. And if you want to solve it, we could, but I'm not going to. I just wanted to show you that picture. Do you want to solve it?
It's just
Yep.
plus 10.
Yeah, we'll do it. We'll do it. So I got 8 squared plus 10 squared equals C squared. So this is 64. This is 100 equals C squared. I got 164 equals C squared. Square root both sides. So the length of my C should be 12.8 feet.
Thank you.
I'm guessing good then?
Yeah.
Okay. Lainey, put the phone away.
Sorry. I'm paying attention. Look at my notes. They're really good. I know
Awesome.
what it is.
Okay. So similar triangle relationships. Gentlemen. So similar triangle relationships. If they're all going to have the same proportion, this is kind of what it's saying. If I have 2 triangles and every single side has the exact same proportion, they are similar triangles. Okay? So you can kind of compare the angles to make sure they match up. Or I can see that this is going to be my longest side. So my longest side divided by my other longest side, so 10 divided by 30 simplifies down to 130. My medium size, so again, longest side, my medium side, that'd be the 6 and the 18. Then my smallest and my smallest. Again, just comparing either the longest sides from each triangle, the middle length from each triangle, and then the shortest length from each triangle. If it is all the exact same ratio, they are similar triangles. Make sense? Okay. I'm just gonna write the extra little note that I explained it as.
Should
Only.
we write those? The A, B.
So
No.
if you want to, you can.
Is it like?
It's just, I need to know that I'm comparing so I'm going to say triangle 1 and triangle 2. Okay, with triangle 1 and triangle 2, I'm going to have the biggest side over the biggest, the medium over the medium, and then the smallest over the smallest.
Okay, I gotcha. Thank you.
Yep. And again, ouch. If every single ratio is the exact same, like these ones are all 1/3, 1/3, 1/3, if they are all going to be the same ratio, they are similar triangles. Okay, if they give you angles, it's a whole lot easier to figure that out because if the angles match up, then you know that the triangles will match up. But if they only give you sides, this is how you figure it out. Keegan, put your phone away. Okay? So, again, this is saying it like 3 different ways. I'm not going to make you guys write this thing because that's the same as this in really simplified terms. Or sorry, that's the simplified terms. This is the really confusing terms. Okay? So I'm not going to go in there. So this is saying, I'm going to start with it. This is saying that these triangles are similar. You'll have one of these in there on Tuesday. These triangles are similar to each other. So I need to figure out how to get that missing side. Okay? The way to find the missing side, I'm just going to call this one triangle 1, and then this will be my triangle 2. When I set it up, I'm going to make sure that my triangle 1s are all on top. All my triangle 2s are going to be on the bottom. So looking at those shapes, I know it would be 8/6, because these ones are both be kind of the same segments. Again, I'm going in between line segment AB and then AB, the complement. And now I get the other triangle. I have 12, and I don't know what the bottom of the other triangle is.
X.
Perfect. If I don't know it, I can give it a variable. I can give it an X. And taking it way back to years ago, I'm going to cross multiply and divide. So I get 8x equals 6 times 12 is 72. Divide both sides by 8. My final answer is x equals 9. Again, if they tell you that they're similar, you're going to set them up as corresponding proportions, cross multiply and divide. All right, same thing for, like, if you needed to find the height of something. Like this one here is saying, find the length of a pole if it casts a shadow that's 20 feet tall. So here's my pole. We'll pretend it's a flagpole.
Excuse interruption, please. There is a blue and tan Bronco parked in the Old North parking lot with its lights on. License plate number 7B-DC3. You might want to go take care of that. Thank you.
Okay, so I've got my first one. This length is 20 feet. That's the shadow. If I have a lady over here, okay, the height of the lady is going to be 5 foot 3 inches, and her shadow is 15 feet. We want to try to figure out how tall the actual flagpole is. To do this one, because again, I've got feet and inches. This is going to be my biggest hint to all of you. Change it to a decimal. Don't go feet and inches. Try to make it into a decimal. So to figure out the decimal for her height, 5 feet's going to stay the same. The fraction for her height is going to be 3/12 because she's 3 inches tall, 5 foot 3. And then the bottom number for that would be over 12 inches because there's 12 inches in a foot, right? So instead of me saying her height is going to be 5'3", I'm now just going to call her 5.25 feet tall. Yeah. Okay. Now that I have her height as a decimal, because it makes it a lot easier, here's my first triangle. Essentially, here's my second triangle. Okay, I don't know how tall the flagpole is. So if I don't know something, I can give it a variable. But the shadow is going to be 20 feet. I'm going to call height and then shadow. So the flagpole is X feet, shadow's 20 feet. The lady is 5.25 feet, and the shadow is 15 feet. Now I get to cross multiply and divide. So I got 15x equals 105. Divide both sides by 15. So the height of my flagpole, or pole for this point, is going to be 7 feet tall. It's not a very tall pole. Feeling good on that? Sweet. That's it. That's the stuff I wanted to make sure I covered. Okay. Just kidding. There's one more thing. I lied to you. There's one more thing that I have on my note card that I didn't cover. And that's to figure out if it can actually be a triangle. It's not going to be on the assignment, but I want to make sure you guys understand. If I have a triangle, so a triangle has side A and side B. No, but I want to make sure you know it. Okay? With these two sides, side C always has to be less than or equal to the length of side A plus side B. Okay? Meaning, if I have a triangle that is 5 feet here, and this one over here is, I'll say 8 feet. The part that will connect, sorry, it shouldn't be even equal to, it should be less than. The part that'll connect this one, in between here and here, if it was exactly 13 feet long, so I add those together, what would this be? Should just be a straight line. If it's not any shorter, if it's not any shorter than that, if it's longer than 13 feet, there's no way that all three sides can be attached together. Does that make sense?
Yeah.
Okay. So again, I know with a triangle like this length up here has to be less than 13 feet or 13 units. Okay, that was the last part. It's on my note that I wanted to make sure I covered because for whatever reason, as I found, a lot of these thoughts don't always go through people's minds when they're trying to do basic things like measure, build things. Just the little simple stuff most people forget about. That was a skill I think you guys covered in 7th or 8th grade, but most people forget about it. Okay. And it is also one of those things that is in college algebra.